JOAJ and the net says welcome. Feel.
Right. Hello. 1 second. What's that? And post it here. I don't need that. Turn it up so I'll hear them. Okay, welcome. I am going to be opening this mystery box of electronics. Now, some of it is just stuff I ordered, but got apparently platinum surprise box, and then where's this one?
The bot says connected to YouTube chat.
There we go.
2b/xat15mmjw.
Oh, my bad. I thought I had another one. Oh, I think it's this one.
JOAJ and the net says technology feed. JOA.
Oh, and let me get some music going. How are the levels? Seems good. I also did buy a bunch of LEDs. And macho magnets. Just a strip of magnets. Could cut them up. Stick things to the desk pretty easily. Alright. Let me just see. So is this the other surprise box? No. Is this one it? No. Alright, it's just one, I guess. Oh no, this is the other one. Surprise box of magnets. This one's pretty simple. I remember now, they just said they'll send 3 random magnets. That's cool. There we go. You can't really see, but yeah, I can attach it to this. Boom. Oh, 4 more magnets. So, put that with the other magnet. It's nothing super exciting. But then this is some of the stuff I got from the previous one, I think. So I've already seen this. But this is the normal surprise box. So here we've got the platinum box. Save this. Got everything. So here we go. Unboxing. Literally. Whoa. Okay. I wonder what this is. Is this a camera or a... Looks like a photo sensor. That's cool. What is this? Ooh, tiny little coils. I'm not gonna get a good view of it. Hold on. I'm gonna pull one of them out. Nope, it just flew out. If I hold this magnifying glass up to the camera, you can kind of see if it would focus. It's just too small to focus on. Whoa. There you can kind of see. It's a tiny little coil of wire. I guess inductor. Wonder if I could use it to trip relay. That'd be kind of cool. Make my own relays. We got more of these. X23202. Let me search that up. I will share the search screen as well. It's not coming up. Use a different browser. Okay, so X. There we go. So X23202. A microwave? No, maybe not. It's different. Bag? No. No. Well, that might just be, this label is just a paper label. If anyone knows what this is, X23202, it says it won't focus, but here, I'll hold it up to this camera. Anyone knows what this is? Let me know. I'll just sort these. Ooh, what's this? Ooh, a switch, but it's like a weird form factor. Oh, a slide, just a slider. That's nice. Potentiometer, probably. Oh, relay. This is already recouping the cost of the box. Well, not quite yet, but if there's any more relays, which I think there are, yeah, we're almost like recouping the cost of the box with these relays. I wonder if they're 3 volt or 5 volt or what. I'll look it up. Let me show this.
Sue Kevin Kotori says Luke get.
Loot get. Welcome. I'm trying to figure out what this thing is, or how much voltage. So, NA5W-K. Now it finds it. Obsolete. 2-pole, 1 to 2 amp. Let me scoot in here. Latching type? Standard type or latching type? Which one is it? Oh, okay, so. Oh, NA, okay. So these are all different, okay. Dash K. What is this star?
Conk Zero says Zimbler bench.
Hey, welcome, Vincent. I'm just trying to figure out NA5W. Okay, there. NA5W-K. So this must be a 5 volt. Uh-oh. Okay, there we go. I'm confused about the coil type, but it's probably just a 5 volt relay. Cool. I'll hide this. Boom. Now you can see more of the workbench. So I already got 2 of these. Let me just see if there's any more. Ooh, there's another one. Whoa, there's so many. 3, 4, 5, 6. Another slider. Some sort of sensor. It's got Sharpie written on it. Whoa. That actually works to focus it. That's funny. Yeah, what do you think of the setup? Let me put a full image on here real quick. Oh boy. Boom. Why is it below that? I put it in above. Oh, because it's smaller. I was confused for a second. There we go. Anyway, what do you think? Ooh, another relay. This one just says 5 volts. This is great. I've been needing some. A bunch of these little 7-segment displays. We can make some number. Could display.
Astrovan14 says some drums I'm studying, so I don't have audio on.
Oh gee, drums. I wonder who helped me set up those drums. Crystal. Oh, some motors.
Hako Tori says, holy shit. Hako Tori says, is that electronic?
This one? Like one of these? Like, when you use these, just like prototyping, and you need to solder to it, you can sometimes like glue it down like this onto a surface, and they call it dead bug mode or whatever. So what is this? IR2432 Sharp 29. Okay, hold on. Because maybe we can do something with this. 2432 Sharp 292C. What? There we go. What is it though? 12-dot LED display driver. Is there an example circuit? Kind of. Where's the LEDs? Okay. 2, 3, 4, 5, 6. So it just controls 12 LEDs? What does it do with those LEDs? Level shifter? Oh, if you don't have enough current to drive a bunch of LEDs? I don't know. Why is it driving them like this? Well, this chip seems kind of useless because I don't have anything that has a weak signal. Here's another one. I should be labeling these. I'm not going to do that right now. No, I should. Do I have sticky notes? Let me go check. I think they're right here, actually. There. So, this is an LED driver. This is the boring part. Put that in there. Alright. SN74LS. 224AN. Flip flop 2-element D flip. Okay, D flip flop. If you ever done Minecraft computers, they use a lot of flip flops. I don't know what color scheme I'm gonna go for, but this seems right for some reason. Wait, am I? Oh, I am in the camera. Perfect. I'm loving this setup so far. Boom. And I'll put this here. Kinda. I feel like they're like hex bugs. If you remember those. Oh shoot. Another one. Is that the same thing? That'd be nice. SN74LS224AN. Yeah. Same one. Stack them. There's a lot of LEDs. Kind of just weird, like this thing with like 2 LEDs in a little box. Oh, another relay. There's a weird button. I think these 7 segments, like I'll just put them with the LEDs. So far this is great, like so many relays. I don't know what I'm gonna do with these motors. I could drive them with the relays. What are these? Probably like a resistor or something. Now that I'm doing this, I'm realizing a lot of this is kind of the boring part. Just sorting parts. But the fun part is seeing like what the chips are and what they can do when you look them up. Standard, like a bunch of the same LED, that's always good. Right, capacitors. Oh, I wrote on my hand. There we go. I can grab the capacitor box. Oh, it's getting full. I'll just put some more in the one next to it for now. Worry about that later. You seem like they're all the same one, which is 1000 microfarad.
Check for us.
Fit check? 1 second. I don't know where the camera is when I'm not looking, so there we go. Fit check. Hold on.
Hako Tori says Pago.
Hold on, I can't see. Put this back. Just balanced it there. And you know, if you couldn't guess, it's a thrift store. Goes without saying at this point. I'm glad you think it's Pog. Imagine doing that in real life. I noticed you from across the bar and I just wanted to say your fit is Pog. Sorry, I don't mean to paint you in a bad light like that. Okay, we're thinning out the herd here. Just like my hairline. I wonder if these are IR LEDs. Let me grab a battery. They're probably just red. That's my prediction. Oh, green. / yellowish green. Cool. But not IR. Because if they were, I would want to put them in a separate spot, so I don't get them mixed up. There's a lot of motors. We could make like an 18-wheeler. Like a little RC car, 18-wheeler. Although, you're supposed to, like a real car only has one engine. So like you're supposed to just hook them all together. So it can make a little robotic hand with like so many degrees of freedom. Oh, I can take the browser source away. Boom. That's a lot better. We got these variable resistors. I already have a bunch of these already. I'm just gonna use these bins and then I'll figure out what to do with them later. Oops. So I'm thinking actually, because I never like need any of these like logic chips. So I'm thinking maybe I'll make a challenge myself to make a project with whatever's in the box, you know? So LED driver, flip-flop so far. We're gonna need a lot more than that to make something interesting. It doesn't seem there's that many chips, but see what we can do. Maybe I can make like a reaction time test or something, I don't know. I can get like a counter. Alright, let's see what these are. Oh, this is different. SN74 LS375N. Oh boy, it's another latch. D-type latch 4-channel. I mean, I can group these together kinda. It's tough because it's like I already have some somewhere up there, but I'll just do it next to I'll just label it separately. Because it is 4 of them instead of 2 of them. It doesn't really matter that much. 4XD latch. I don't remember the difference between a latch and a flip-flop. Okay, and then CD405 1BEX. What? Oh, the X, the lowercase x is like anything. Ooh, selector. Analog multiplexer. That is really useful. Analog. Mux. Demux. Mux means multiplexer, and which means it's like a switchboard for if you think about like the old phone system, they'd have the operators and they'd be able to plug the things into different ones. It's sort of like that. And another one. Alright, these will help us make something complicated. Especially that it's analog. And another one, like DJ Khaled over here. And different. Oh no, that's another 4X D flip-flop / latch. So let me make sure I don't leak anything. Okay, it's just Mastodon. LED. There's some 2-color LEDs. Actually, yeah, we could do something with these. I'm gonna put them away for now, but remember that I have them. Okay, I don't know what these are. We're reaching the dregs. I'll just put those in here because, well, I'll determine what this is if it's going to be helpful to the project. I can't, it's like GO2, JE. What is that?
Hako Tori says, JC, can you pretend to use the electronic bugs to walk across your electronics board? Hako Tori says, oops. Hako Tori says, JD.
You pretend to use the electronic bugs to walk across your electronics board. Now that's an idea. If I could get some sort of belt and glue it to it, it would go like around the thing. Sort of like it would go like, except like a longer, like a tank tread. Or do you just mean like just do it? Which one of these tweezers is longer? Try that one. I already sorted them all. Sorry. Oh, this is a weird type of tweezer. Normal tweezer. Are you ready? You can see the tweezers very clearly. Oh, there's a bug on the edge of the screen. Whoa, it's like an edge bug. There you go. Okay, what was this component here? NPN. Okay, so it's just transistors. There's a lot of them. So if I could find use, I can use them. The important thing is the inputs and outputs. We don't have any buttons, we just have on-off switches. So, and we've got only 4 of them. So what could we do with 4 on-off switches? And then as far as the output, we've got all sorts of displays, our 7 segment displays, and LEDs, even 2-color. I could make a thing that you press it and it cycles through somehow a bunch of options. Because I was thinking initially you have 4 of these. You could use those to select which thing on one of those multiplexers. So I'm thinking I want to make some sort of game. or device that does something interesting. Like this whack-a-mole. Maybe I could make whack-a-mole with these. I'd need a lot more circuits to do that. This is not enough. So I have basically 6 storage like bits, and then 3 of these multiplexers. I don't know if I can do. Then a bunch of transistors. Those would help. How many do I have? Maybe about like 15? No, less than that. Maybe like 10. Oh, but then there's another type of transistor. MPS W06N719. What did I say? MPS? MPS. There's spaces in between. Not coming up with anything. Okay, 1 watt amplifier transistors. NPN. So these are all NPN. And I've got about 30 if you include 20 or 30 if you include the other type. I do have relays, but I'd rather keep those for other projects. Because those can do logic if you hook them up the right way. Okay. If I wanted to make like any of the classic games I've made before type thing, that would require a lot more. So I'm gonna have to get creative here. Do I have anything I can count up? I could make an adder. Why don't I allow things from previous box, like surprise box? Or no, I'd rather not, because then that project would get too hard to like make really quickly. That'd be a lot of soldering. Okay. What if I could do something that like rolls the dice? That would be cool. Just picks between a bunch of options. You press one button, rolls the dice. That could be good. So I'd need 7 LEDs. There's 6 of here that are the same. That's unfortunate. 2, 3, 4, 5. 1, 2, 3, 4, 5. Dang. Oh, 6. So these are 2 different types here. Might even be more than that. And I've got a bunch of these that are inside this thing. Might have to use those. Or the center one could just be blue for some reason. I guess that's not the end of the world. Let me test these. Orange. Oh, and green. That's right. Wonder green, then what is this? Green, red. Ooh, what about a... Yeah. How about a random number generator that just gives you a random number on one of these? That'd be kind of cool. Get out some paper. And give me another box. I'm gonna keep those out. I'll just use the one that's odd one out because then I can save these for later to use together. Although this one's also different. Do I have capacitors? Yeah, I could use a capacitor to generate the randomness. I don't think that would work actually, because it's a very predictable curve. Okay, how can I do a delay? Oh no, I can just do some sort of loop where it charges and discharges quickly, and based on when you press it, it just reads the number at that point. That could work. Okay. Yeah, and with a flip-flop it'll determine the if it's charging or not. And even I could use a relay if I run out of ideas there. Okay, let me get drawing up here. It's gonna be interesting. Okay, so I'm gonna have some circuit here that converts a number into an actual number, like converts the format, because these you can just turn them on individually. But if we have a number coming in, we need to convert that to the individual, like LEDs. And we can go up to 0 to 9, and we can even go A, B, C, D, E, F as well. And so that would be either 4 coming in or 16 coming in. Alright, back to the data sheet. This is 8 channel. I don't know if this is going to help us. Oh no, it will. Because we just put in random for 3 of these. And we have, how many of those? 3. We have 3 of them, which we could do 2 of them, so that's 8 and 8, and then to pick between them a third one. Which one's this? 4051? Yes, that's this one. Okay, and then we need 4 random bits that just goes 1 and 0. That's difficult. We don't even have any resistors, unless these are resistors. That could be, this is going to look so funny. C2206, B40, C3700, 2200. It's a diode-ish type. Bridge rectifier. Okay, so it's the 4 diode kind of thingy. That's no good. These coils might have some resistance. In fact, I have a tool for this, but I'll just use this because I already got it out. Okay, very low. Very low resistance. I think this is gonna work. 0.6. Okay, wait, it's changing. Okay, 1.6 ohm. Does this thing have resistance? Maybe the diodes will help me with. Swap them. So it's got like mega ohms. These are resistors, and this will help me get different values for each one. So I just need to reinvent the 555 timer. $7.6K. Okay. So it goes anywhere from 20K down to 0. Nice. So these sliders are going to be really helpful. I forgot I had these. So, can I make a 555 timer? Is the question now. Because my idea is to have 4 different timers. Is it 4? Yeah, 4 different timers that go on and off depending on the... or just at different speeds. So... oh shoot, then we need latches. Oh, I have latches. Okay, I have a 4x latch. So 4 that go on and off at different speeds. When you press the button, it saves those, so it'll stop moving, and then that'll display to the button, to the display, the 7 segment. This is gonna work. This is gonna work. So I gotta figure out how to make a timer actually, if that's possible. Build your own 555 timer. Okay. Oh no. No. Okay. So I need 4 of these. This is pretty cool though. NPN, and I need PNP, so I can't do this specifically. That's cool, you can choose values that are... oh, and I don't have a bunch of resistors and stuff. Okay, so I can do maybe an oscillator. RC. I don't think I spelled that right. Oh. Okay, there's more Mastodon. Let me just check Mastodon real quick. I'm getting notifications. Someone hates my mouse pad hanging off the desk. If I moved it, then how would I get to my laptop? It's functional. I'm being real, you know? How many of y'all at home have a mouse pad leaning off your desk? Looks sweet, but it could do with a spinny chair. That's a good idea. Okay, so that was replies. I thought it was like just favorites. So I have an office chair, but this one's pretty comfortable, and it has like built-in rocking. Jeez. Anyway, how to make an RC oscillator. This is probably what I want. What is this? Okay, okay. Just I forget. NPN versus PNP. NPN. I forget which one we had. NPN, we have NPN. So, get a breadboard, some wires. And done with this for now. Okay, so I'll draw out the full thing now. This is our resistors, I guess. So we've got our 7 here, 16 here. The dot we're gonna ignore. Then here we need to have our decoders. Eight lines here. 8 lines here. And our other decoder to switch between the decoders somehow, which we'll just use 4 of them connected together for one, the other 4 for the other, and then this will just have, so this has these 3 lines coming in here, which will connect together to the other 3 coming here. Then the last one here will do that, and then these last 2 will just go to ground. So then we've got our 4 inputs here that we need our 4 timers for. So, for example, one of them would go into this entire circuit that you're seeing on the screen. Is it still up there? Yeah. Oh, it's very faint on the paper here. So this entire circuit right here, I'm not going to draw it, but times 4. And that'll have our transistor. I guess we'll need more resistors. We're gonna need way more resistors. What's the resistance of these motors? Because if possible, I'd like to stick to the original plan of, well, I guess it wasn't original, but the plan of only what's in the box. Okay. It's going up. It's like 3 ohms, 2.5 ohms. That's not good. I mean, these little thingies here were also, where did the box go? There it is. We're also like 2 ohms. The resistance of the relays. Hold on, let me show you. Moment of truth. I mean, I already saw it, but that's a little bad connection here. I'll try again. Oh, it's different now. 180 ohms. So we have 180 ohm resistors. They're very expensive, 180 ohm resistors, but they're there. So we need 16. So we've got 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Oh, I guess 17. So we've got 17 things that do provide resistance. Let's see if we can pare down this circuit. Oh, and there's more capacitors. Regenerative feedback. A ladder. Store charge. Feedback can be connected as above. What's the simplification of this, though? Is there any way to simplify it further? Because I don't fully understand the circuit, even though this is what I studied in college. Like, I get the idea, but we were just doing the math on these kind of things, and then I was making circuits that were not like this, more digital. So it's having the two connect. And also I forgot most of the math. I could just read the whole page here. It's probably the solution. But let me just think about this. So the transistor acts like a switch. When this is high, or high enough, it'll turn on. But what does that even do? Oh, because these are connected to the capacitor. So let's just ignore these left two and just do 1. So when it's on, this capacitor will somehow drain through here. Through there. Yeah, that's the loop. So these are, oh, and this is ground. So we do need both of these. And yeah, we need all of those, I think. Those 4. Maybe not this one. No, because we would... Yeah, maybe not that one. And then maybe not this one too. No, that would be bad if that was shorted to ground. So these got to be one of those. And then capacitor. We'll just look at this outer one. Ignore the 2 inner ones. Maybe we could get rid of this one. No, because it needs to do a voltage divider. For testing, let me build it with like the right way. How much time do I have? Yeah, we have several hours. Okay. For testing, I could just build it with what's it called? Actual resistors. But let me scale this down. We don't need 16 numbers. For now, we could do 1, and that would work with these sliders. Do those even plug in well here? No. No, I can kind of redo on the edge here. Yeah. Can finagle it if it's on the edge. So I'll just do 1 for now. And see if we can remove 1 or more resistors. Oh, this one's broken. No, it's not. It's on the other side. 'Cause it's flipped. This could be useful for us other stuff too. Like the ability to plug this into a breadboard. Okay. I could even do them like this if I needed to. In fact, I'm going to do that. Oh no, I can't because then they'd be all connected. Okay. That's good. Obviously, I can't do this without wire, and breadboard. So that's kind of the most I'll allow that's not in the mystery box. And are these capacitors too big? I guess they'll just be really slow. Okay, so now let me get these to be really high to start with. So, toward the outside is high. That's good to know. Oh! I'm dumb. I have these way too many of these ones. So I probably can do 4. I wrote these off, but these are going to save my life here. And these are more valuable. I'll save these for something else. Much better here. No, I'll measure it first. And it's definitely 16. Okay, 170K. That's even better. Just higher values, because then I don't have to waste as much power, which could, like, I don't know, heat it up. No, 20K was fine, but I don't know. This allows the timer to be slower, which I guess I don't want, but I don't know. I just don't want it to explode or heat up or anything. And it already wasn't gonna. Okay, so these I can just use however I want. 2, 3, 4. 5, 6, 7, 8. 9, 10, 11, 12. 13, 14, 15, 16. And these I have no problem just using up. Because, I don't know, they're not that fun to use compared to the sliders. Dang it.
Hako Tori says, I know it would be a hassle, but can we get a Chillville on the BG for one rotation?
Sure. It's not a hassle. Problem is, when it ends, it's a bit of a... That is the hassle, is like getting back to... Or like, because I don't have the headphones on. But I can just put it on loop. There it is. This volume good? Looks good. Maybe a little louder than the other.
Hako Tori says, very nice.
There we go. I'll give it a listen. I haven't heard it in a while. Okay. I also need to supply voltage from that all the way here. And yeah, I guess that'll work. I didn't check the voltage requirements on these. I hope they run on 5 volt. Okay. And I'll turn this off for a second. So you can see, well, you can't really see over here. You can see on the big one, I got this power supply. And I'll just hook these in. Alright, 5 volt. And ground. Okay. Just make it a little longer than we need. Or no, because then it's gonna get annoying. I'll make it that long. All right. Plus. Minus. Feels good to just be using the supplies and the tools, you know? Been setting it up for so long. Just actually getting down and using it. I've done it a few times, but like, feels good. Haven't done like a breadboard project in a long time. I've been just like freewheeling and just soldering it up because I'm like pretty confident it's gonna work. But this one I'm pretty confident it's not gonna work the first time, so I need to breadboard it. Or I was taking things I had already breadboarded and added it.
Productive arc FRFRDJBRONICHIPOGU.
I like how it spelled the emote. True. Who knows when it'll end though? That is always the worry. DJ Bronkinichi Pagyu. That's funny. Just read the letters. Okay, let's test that it's working. Turn the power supply on. Light came on. Voltage. I have to unplug them for this. We are getting 5.1 volts. That's great. Let's do a quick LED. Yeah, look at that. You can change the brightness. Whoops, I may have burnt out the LED by changing the dial too far. Yep. You can see the burn marks on it. That's what I'm talking about. I don't want to risk it for the biscuit. I just killed one of my components. I'm just going to bend the lead so we know it's bad. I mean, I should just throw it away, but maybe I'll smash it open. Well, you can see inside there. There's a burn mark. But this is all just 5 volts, not super bad. Like, it's not gonna like kill me or anything. But it will kill a component. I definitely smell the magic smoke smell. If you ever had smoke flavor, it is a similar smell to the electronic smoke. But this one should still be good. Alright, now we gotta build this circuit. Show it again. Okay. And I'll put the ground over here. So that way, visually, it'll be kind of similar. So I can think about it better. Alright, so then on plus V, we've got a resistor coming out. That's not long enough? Alright. It's gonna take a while. These things are not bent properly either. I'll bend them a little more before I plug it in. Okay, so I made a wire. Now we go resistor. Oh! I can just use, oh, it says 200K on it. I can just use the entire resistance of the thing and not the variableness. Yeah, the total is 200K. Because the way it works is you've got like two resistors together. So like your voltage comes in, it's dissipated by one of them and then the other. And then you get that in-between point. So the voltage is going to be in between 5 volts and 0 volts. And that's how you have the dial. It'll change which point it is. I'm going to turn off looping, and then when it's done, we'll go back to the original playlist. Yeah. What was I saying? Oh yeah, so then if you just do the endpoints, that will give you 200K. So, we've got a 200K resistor now. That's RL. Then we need our NPN. We need 4 of the same NPN. Not to be confused with NPM, which is a software thing. These look the same, but I'll look at the numbers real quick. Oh, you can't see it. These ones. And we also have these ones. If that doesn't work, there's a lot of those. Yep, the numbers are all the same. Now, yeah, I gotta look at the data sheet for those. Is that this one? Yeah. Yeah. Back view, that one's, so this is the back view. So it's like this. I'm gonna draw a little diagram so I don't forget. Three, two, one. And 3 is emitter. 2 is collector. 1 is base. And then, this is NPN. I'll look at what that means. There we go. The one on the left there. So, base, emitter, collector. See, I'm refreshing my knowledge at the same time here. Okay, we're back to another playlist. And go back to this circuit. Let me see, is there anything else I should know? Not that one. About this one. 0.5 to 1.5 amps. Oh, not sure. We'll give it a try. Okay, it looks fine actually. I don't know. The voltage ranges seem fine. Back to this. Now we have the piece. Oh, there. This piece that we know which pin is which. So this needs to go to the collector, which is pin 2. So we'll just put in a wire. random wire. Oh, I got the right length first try. See, I was going to move this, but I don't have to move it. So that's pin 2. The middle one there. It's kind of small on there, but whatever. So this is our RL. Then we've got R1, which also goes to a resistor and then to pin 1. Actually, we'll make this our R1. Oh, no, because I'll keep it to the diagram. So this is R1, which we'll grab a quick connection. That goes to base, which is the middle, or the thing here, which is pin 1. So the one on the right. I should make this more compact, but I'm going to do that later. Premature optimization is the root of all evil. And I'm not ready to prune the tree yet. That being said, I did make one small optimization there. Also, I will get rid of the voltage here till we're ready. All right. That's R1. Now RE. Let's put that down here. And I'm realizing the error of my ways. I need some room here to get. Oh no, I don't, because I can. Actually, I do for the next one. Not for RE, but for whatever the one after is. There, we can just patch that in. That. And then this one. Goes like that. So, because that's the emitter, right? That one? Yeah. And then it goes to ground. Let me just take this out. Okay. These are all 200K. Okay. And then R, just not labeled. I guess that'd be RB from base. That one. You know, I want to flip this. So that I can reach the other one. No, I'm not going to flip it. I'll just cross over for now, and I'll flip it when I do it again. Just need to test this. So R1 also went to base. But this one's going to base and then to ground. There we go. Whoops, there we go. So I got our 4 resistors in. Now we need a capacitor between base and collector. So I'll just put that over here. Now which way is it going? Because these are like... Oh, we can combine two capacitors to give it half the capacity and make it not polar. So you just connect the minuses. Okay. So let's do that. These are 1,000 microfarads. So that'll be a half that. So, between base and a collector. So collector is pin 2 and base is pin 1. So there we go. In fact, base is over here already. So commandeer that. Alright. What did I say? Base and collector. Collector is pin 2. That's that. So this should be it. Ah. There we go. I have enough capacitors, so that's good. Alright, now we need to measure the output somehow. I mean, with this, but we need to get some wires real quick. So minus, and then our output is the collector, so that pin 2. There we go. Now we just got to measure this voltage, see if it changes. So for that, oh, I have test points for this. Where's the other one? There. I don't need these jerry-rig ones. I have better ones, other jerry-rig ones. So it's not plugged in now. So we get nothing. Now I plug in the power. We should see the voltage change. Okay, it's going up, it's going up. We've made an oscillator! Oh, that's so cool. I'm gonna connect an LED so you can see visually the brightness change. This is so cool. I'll leave the probes connected as well. And I'm running out of spots to connect. There we go. And I need a resistor as well. Come on. Alright, let's do it. Moment of truth. Oh, I gotta make it a little brighter. No? Seems it has modified the circuit enough. Oh, the pin came out, that's why. I'll just measure it from here. 2.6, 2.7. So now it's just hovering at 2.7 volts. As before, it was actually oscillating. I removed the LED and it's still doing that. 2.5. What did I do? Did I bump this one? Oh, these are all the same anyway. Okay, 2.8. Okay, it's going up slowly. So this is the capacitor charging. And once it gets high enough, it's going to drop. So we'll just wait. And then I'll change the values and we'll try and make it go faster. We've created a really slow timer. It's pretty cool. Because the way it works is a capacitor is basically like two metal plates next to each other. So when you apply a voltage, the electrons flow into one side and then they get pushed away on the other side. But it has a limit. It doesn't allow flow forever. It'll fill up with electrons. And then you can slow down that fill by putting a resistor, which is basically just a really long wire that has a high resistance, or a material that's not quite as conductive has a high resistance. Okay, we're up at 3 volts. See, this is more what I expected. I don't know why it was going up and down so fast before. Bad connection, maybe, to the voltmeter. So yeah, you slow down the charging with a resistor. And then the way you get it to discharge is once it charges up, you switch it so that it has a path for the electrons to flow the other way. So that's what this transistor is doing, apparently. Yeah, once it reaches high enough level, it triggers the transistor because it has like a trigger voltage, and that allows flow through it, like up to down. My mouse isn't on the diagram, but like on here it just goes from collector to emitter. The base triggers it. Okay, 3.1. I'm gonna try and I'm gonna get some water. Oh, I have water here. I don't know. I'm gonna just sit here and wait until it triggers, and then mess around with the circuit. But yeah, these resistors are super funky looking, at least, because they're variable resistors. They're just kind of funny to see so many of them on a board, I guess. I can just watch it in OBS. In fact, something to prop this up would be good. 3 of these bridge rectifiers should do the trick. I'm just going to put these with the LEDs. Where did I put the LEDs? There they are. Because I'm not going to use those, I'll use the odd ones. Chat, let me know if I missed the number dropping quickly. I mean, it's going to be pretty noticeable. If the apocalypse happened, maybe you would be able to cobble together some electronics this way. Although, depends to what degree we're talking. But I like the strategy of using variable resistors, 'cause then I just get whatever value I want. But like, none of this is going to be useful. That's the problem. I can't make any sort of communication devices with all this. I mean, maybe an AM radio. But it's better just to buy a radio before the apocalypse happens, and then you're good. Am I really just going to sit here instead of tweaking the circuit? I mean, it's sunk cost, but I've already started. And the decimal is right here. You can't really see it. 3.375. Hey, at least it's not Desert Bus Simulator. I have a feeling once we get to about, like, closer to 5 volts, I mean, that's the cop-out answer. I'd say 4.2 volts. That's going to take forever, isn't it? And it counts up slower because the capacitor, as it gets fuller, it's harder to fill up. It's like pressurizing a tire or something. So, it's not going to reach that. It's going to take like 30 minutes because it's slowing down. So I will decrease the values here. Just a small change. Oh man, I lost a lot of it. Oh, now it's going way faster. I should have just done that ages ago. I can just watch it in OBS. So now it's at 1.9 volts. Oh, it's slowing down again. Let me decrease the other one as well. Or L, it would be. Yeah, tweezer pliers work. There we go. It's charging faster. And I can speed it up even faster. That's better. Now that I'm thinking about it, I think I can use like transistors as diodes, but I don't need a lot of them. Don't know if I'll have enough. The diodes are for the display. 2.8. Converting the numbers into actual, what's it called? Segment. On off. Okay, we're back around 3, but it's going a lot faster this time. And these capacitors are like huge. 1,000 microfarad. I would rather have like 1 microfarad or 10. So it's just taking so long to do it. I guess it's 500 microfarad. It's unfortunate. And if I made my own capacitors, they'd be way too small. Just with 2 metal plates. .6. Still gonna have to wait several minutes, but not several hours. Let's just get a reference for how far these things go. Oh, they go a lot further. I was scared to change them. Oh, did you see that? It dropped down again. Oh, my meter is complaining that it's on for a while. 4 volts. And then it's going back up. I don't know why it changed the decimal point, but I thought it was 0.4, which would have been a lot better. Oh, and maybe we can plug in the LED now. Why is the LED not working? There it goes. Okay. 1.8 volts. What happened?
Spin says GPU or Zo NPC AUT Opix 20M.
Get out of here. Where's my modded? Ban that. Done.
JJ says clear.
Anything happened while I was not looking? See, now it's stabilized at 1.7 volts when I add the LED. Oh, there we go. And my thing was had a loose connection. 2.6. If you notice it jump down when I'm looking away, let me know. I'm trying to make it even faster as well. 5.1 volts, and it's not triggering. Oh, because of my ratios for the triggering. Okay, so I've got to lower. I've lowered RL and R. Now I need to lower RE, I think. So it'll actually trigger. Because the transistor voltage is just not triggering. Or maybe R1. Maybe all of them. I don't know. Either way, definitely need to lower all of them, so I'll just do that. Now I just lower this until it jumps down. Yeah. No, it's not happening. Oh, I'm measuring. No, I'm measuring the right thing. Okay, I'm getting rid of the LED. Still not jumping down. Okay, let me raise it. Okay. It's lowering. Does that mean it's on right now? Because it's supposed to be a sine wave. It doesn't just jump down. I don't know why I was thinking it would jump down. It's so annoying I can't see the decimal point. There, if I angle it better. There we go. Now I don't have to keep glancing, I can just look at OBS. So what can I do with a slow timer? Ooh, I could do some LED fading. I have a 2-color LED. Fade between colors. Why is this so slow? Thought I reduced all the values. Okay, now it's going back up. We'll see if it goes back down automatically this time. Because I did tweak some of the stuff and it might have triggered it where it had no business kind of triggering. The thing I don't get is how it stays on for so long without latching somehow. Like, I don't understand the trigger mechanism well enough. How can I make the capacitance even smaller? Let me grab my capacitance meter. Oh, this has a capacitance meter. Well, I have a different one though. So then I can see if our coil components have a capacitance. Okay. So this is just like a little component tester. So for example, 200K, should say. There we go. 200K ohms. Now we grab, there's those little files there. Where's the third one? Probably under here. No? Whatever. Wait, why would these have capacitance? That's stupid. Zero. Yeah, 2.6 ohms. If I put them, oh shoot, I just dropped it. If I put them next to each other, do they have capacitance? Is it even worth trying? Well, we're down one component, but I don't think these are going to help us anyway. And I don't think it's worth trying. It's going to be so small. Okay, 3.9. See, that's what I'm thinking, like, it just settles on a value. Why would it not? Based on my understanding of the circuit. Is that what the other stages are for? I'm not really sure. If I can tune that value though so that it oscillates around a certain value, maybe that would be good. Let me try one more time to try and get it to trigger. Now I got it to go back up. So 4 volts. I basically have a dial that I turn it to something, and then the voltage like finds its way to that point. And I turn it again, it finds its way eventually. And it may or may not oscillate around that value. You have to be rigorously tested. So if I find the trigger value of our latches slash flip-flops, maybe we can do something like that. Let's just let this simmer and see what it does. I think the multiple stages is necessary. The output is only on the last one. Yeah, because it cascades through them. I mean, hey, I do have enough capacitors. I don't know if I have enough resistors for 3 stages here. I mean, I guess I just need 2 more per 2. I have just about enough, so I could build the full circuit. It's just going to be big. I think this is already working so well that I'll just build the full circuit here. Oh no, my mic's been working all the time. I think, yeah. I think I'll build the circuit. So let's disconnect the power. Turn this off for now. You can see now it's going down because the capacitors are all draining. Actually, I don't know if I have actually enough for all 4 of the 3 stage. 2, 4, 6, 8, 10, 12, 14, 16, 16 there. Why did I dump them out? I could just... So 16. So I have 4 per, so I have enough for a 2 stage. So we'll try that. And I need 1 more resistor. If I could just get by with 1 capacitor, that would do it as well. So let me think about this. Oh, here's my... So, RC with polar capacitor. Yep. Yeah, I probably should have just read the whole page on the other one, shouldn't I? Total of 180 must be provided. Oh. Okay. So we can use polar ones. So the curved side is minus. Just gonna write that down here. Minus plus on the flat side. And the capacitor, oh, the curved side just goes toward, the minus just goes away from the thing. So for these, minus would go on the left. So I'll just draw that halfway in here. Minus. There we go. Just to remember. Alright. So now we do have enough for a 3-stage. So that means we need 2 more here. Which means we have to dip into other types here. 2, 2. We have just enough. 2, 2. Oh no, we have 2 extra. So let's see if we can. In fact, this little meter. Oh, easier to measure a quick component here. Nanofarads, this thing's... Okay, there we go. I had my fingers touching it, so... 1 M? 1 mega ohm? I guess. Whoops. Okay. Oh, my finger's touching the components again. Apparently humans have a large capacitance. Okay, so 0.5 M, so 500 K. Oh, it says 1 M on the thing. Great. Oh, I should check. If I turn it to the right. That decreases that one. Makes complete sense. I'll try and use these for some other part of the circuit, but just keep in mind they're 1 M and they behave as expected. Alright, so first order of business. We don't need as many capacitors. And the minus goes away, so the one that's connected to the base, which is pin 1 there, that gray pin. Oh, did I do this wrong? I had it between. Oh yeah. So this one's the base. Is that just the end of the playlist? Oh, video pause. Continue watching. Yes. Okay. So the one that's the base, which is this one, double check, yep, is plus. And then the minus goes up to the left, and eventually it gets around, well, I'm going to redo that anyway, so. Since we just have one, it's less finagling to do. So we got the base there. To plus. That's good. The minus is off to the left. Then we gotta put another one with the minus off to the left. And then we'll connect them with a wire instead of trying to squeeze them. It's a little too short, but there we can squeeze them a little bit. And then a third one. This is going to be so cool when it works. Alright. Now we need to grab, I'll move these wires up here. Three resistors. And two more resistors, because this one's here already. See, I'm learning about phase shift. It's crazy. Like I learned it before, but now I'm like, oh, that makes a lot of sense. Because it just takes time for it to charge up. And the phase is just time, like, in like a circular sense. Like if you have something oscillating. Alright, and then so we've got this one, this rightmost R done. We just need two more, so and we need the back connection back to the original. Do that first. There's something satisfying about having a bank of capacitors. I'm a sucker for storage, even if it's just storing electricity. And that goes where? Around to the top pin, which is the collector, which is the middle pin on here. There we go. So that is our feedback on the diagram. That's that. Alright. Now what? Two resistors. Let's grab two ground wires here. I like to color code them a little bit. Just been doing yellow for ground because it's short enough. I wish they had a short, like, black one or something for ground. Actually, let's do the bridge over here first. Oh, I'm using yellow already. Oh. We got that one, now we need this one. Maybe I should just use orange for ground because it's the right length. I'm already using it for plus though. They're so far apart. It's too late now. Oh, and these need to be offset. by 1. I don't know why I redid that. That works fine. I'm just going to put it back. All right. These are too close. That would be good. And those, okay. All right. In theory, this should work. Just exactly how it is. All right, 0.3 volts, 0.4, 0.5. So we'll see. It's gonna take forever, isn't it? I'll just decrease the Let me experiment here with how far to slide or to move the contact to decrease it. 0.9 ohms is the minimum. So you gotta not do that. That would be dangerous, I think. Not sure though, actually. 1 ohm. 23 ohms. 0.8k ohms. It drops off quick. Oh, I can just measure them on the board. $194K. Oh, I moved that the wrong way. Oh no, I didn't. I just measuring the wrong one. It's hard to get in there. 163 ohms. That seems pretty good. Why is it going so slow? I mean, it's 1,000 microfarad. I need much smaller capacitors. But this is it's a fun challenge though, to try and work with these components that are not exactly what I like ideal. Reaching 4 volts now. Now it's going back down. No, it's not. It's stabilized at 4. I think the capacitors are way too big and it's messing it up. I'm going to temporarily replace them with small ones and see what happens. Let's just read the document to see what value would be good. I'll grab the capacitor bin and I'll read the document. Jesus, don't want to bring down the whole stack here. There we go. The frequency is 1 over 2 pi RC squared root of 2n. What's n? Number of stages. Alright, so 1 over 2 times pi times the resistance, which was about 200 ohms, times the capacitance, which is about 10,000 times 10 to the, so what's micro? That's -9, I think. Farads times square root 2 times 3. So it should be 324 hertz. Why are we getting like 0.001 hertz or something? Oh, it's going down again. Is it an oscillator? Is it oscillating? I've created an LFO, low frequency oscillator, joining the stream.
JOAJNDNet says welcome.
But that shouldn't be broadcast to everyone. That should be to just that user when they join. Either way, so it's still going down. Let's see here. Sufficient feedback is needed. Must be provided. We need adequate gain. It's pretty cool. So these are the capacitors. There's like a phase shift. And this is the transistor. It's the gain. Or like a delay almost. So this is like, make this high, and this goes up through, and it's like, oh, it's high, and now it's high, and it's like, make it low, and it's low, it's low. So then that's how we get like a sine wave. The way it delays, I guess, is like charges one capacitor, which charges the next, which charges the next. Okay.
JOAJ and the net says gaming feature this stream.
I think the stream might have just died and then restarted or something.
JOAJ and the net says music. JOAJ and the net says programming.
My finger on the mute button there. Did I use the right units? Oh, I'll just look up 1,000 microfarads to farads. I know it's dumb, but I just... Okay, I'll just use this. 0.001 farad. So I think that's probably where my calculation was wrong. Oh yeah, to the -6. Times 1,000, yeah. So 0.32 hertz. So it should be oscillating 3 times a second. But it's oscillating like 3 times a year. I don't know, not really, but like it's much slower. I mean, these variable resistors are probably way higher than I put into the equation. So let's say they're like, instead of 200 ohms, that would be what I want. Let's say they're like 2,000 ohm. Wait, why would the resistance higher make it faster? Wouldn't that make it slower? And it is going back up. So that's cool. I've created an oscillator. I didn't think that was going to work today, so that's good. Got somewhere. Just really slow. But why would... This is the frequency. So the lower the frequency, the higher the time. Oh, I see, yeah. So 0.3 hertz. Alright, that makes sense. So let me just get rid of the 1 over. So 3 second, okay. So 1/3 of a hertz, so 3 second. Okay, so if I increase the resistance, we can solve for it. But anyway, it's about, I don't know how long that took to, uh-oh, has it just settled on a value? No, it's just going really slow. No, it has settled on a value. I think my phases are all messed up because I don't have the same resistance, so it might be canceling itself out or something. Like if they're charging at different rates. Alright, so let's standardize our resistors. $172 ohms. Haha, 17K. Oh, I was reading the wrong one. Dang it. No, I was reading the right one. It's just really high for some reason. 17K. Okay, so that's our problem right there. I guess these are not calibrated either. Okay, now we got 87 ohms. Let's go higher. It's a smidge. Now we got 500. Dang, a smidge really does a lot. Still 500, okay. $245. 80. 90. 166. That's close enough to 170, whatever. I'm willing to go with that. Oh, that's another problem. My stuff was misaligned. So the circuit was also built wrong. Okay. So that's the third pin. That's B. So on this one, that's fine. Okay. On this one, shoot, I was connecting extra resistance. That's why it was so slow on this third R. So this one, base goes before, so this just needs to be adjusted by 1. Well, I'll just do this one. This one over. Yeah, those were supposed to be connected and they weren't. Alright. So now I gotta go calibrate this one. $38K, way too high. $278 ohms. Just need to be a tiny bit lower. $172. All right, that's close. So I think the other one was exactly 172 as well. Okay, get this wire out of here. Okay. Still a little slow here. It might be just trying to reach a level and then it'll oscillate between. .062. Okay. Let's put 172 into the. So I should be seeing a change or a cycle every 2.6 seconds. Oh, it went back up? No. It is going up. Why is it still really slow? Alright, let's calibrate the other resistors. R1, RL, and RE. Doesn't really say what it should be. Oh, that's probably based on the transistor datasheet. Let me just make them really high. Okay. So I just settle at a new value. So I don't know if I've made an oscillator anymore. Give me some resistor values, please. There we go. No, they just give these, not these. DC operating point is established by those resistors. Oh! It's going back down. Or was it going back down before already? I feel like I'm losing my mind here. Was it going up before or down before? Be a good time to stop, just recoup, get it tomorrow. I feel like it was definitely going up before. I'm gonna check the VOD. It was going up before. Now it's going down. If we could see it go up again. 2.6. Be nice. Oh, it's this one beeping. There we go. Oh, there's the third canister. These things. Maybe I'll try and make an amplifier first. Like, just get that part working. Anyway, I think I'm gonna wrap up here. Well, I'm going to call it here for today. I'll pick it up tomorrow. The plan is to just break the circuit apart in half, do one half at a time. make sure the amplifier part's working. But yeah, when I opened the surprise bucket, I was just gonna look and see what was in it. But then I realized, yeah, let's just make a circuit with only the parts in there. So it's been super fun so far. And we'll see if we can get something to display on the number display tomorrow. All right. Jeez, I'm getting all these notifications. I guess that's Mastodon again. All right. We're gonna raid Diggity, who we've talked about electronics before, so I have a little bit of context of what the heck's going on. Forget if I've shown him a picture of my setup or not, but